Okay guys, today we're going to do 9-4, composition of transformations. A composition of transformation is one transformation followed by another. So it's two. For example, a glide reflection is the composition of a translation and a reflection across the line parallel to the translation vector. Okay, so what that glide reflection means is we start with our pre-image right here, this blue triangle, JKL, and we translate it across this vector. So we slide it, we get triangle, this green triangle right here, and then we reflect it across the reflection line L and end up with our image right here. So it's 1, 2, composition, transformation. Okay, this is just saying that a composition of two isometries is an isometry. Alright, so what we're going to do here, let me find my ruler, is we're going to draw the result of the composition of isometries. Reflect this quadrilateral across line M and then translate it along vector V. Okay, so when you reflect, remember, you got to draw lines perpendicular to the reflection line, and I'm estimating here, you all should be more precise, okay, and then we measure point P to the reflection line, point S to the reflection line, point Q to the reflection line, and R to the reflection line. Okay. So I just reflected quadrilateral PQRS across reflection line M. Now I need to translate it along vector V. So this is where you draw the parallel lines, each vertex. Okay, measure vector V. Okay, let me make that a different color. Let's use black so y'all can see that. So you end up with the image there in black. So we reflected and then we slid it. Okay. Now we're going to draw the result of the composition of isometries. So we have triangle KLM. K is 4, -1. L is 5, -2. And M is 1, -4. And we're first going to rotate 180 degrees. So the rule is opposite your X, opposite your Y. So then we have -4, 1, -5, 2, -1, 4. So I'm going to go ahead and graph that. So we just rotated 180 degrees. Now we need to reflect across the y-axis. The rule for that is opposite your X, keep your Y. So our image is going to be 4, 1, 5, 2, 1, 4. 4, 1, 5, 2, 1, 4. And there's your composition of isometries. Okay, I'm going to be quiet. Let you do this one on your own. I'm going to let you all graph it on your own to save time. Okay, the composition of two reflections across two parallel lines is equivalent to a translation. Okay, the translation vector is perpendicular to the lines. The length of the translation vector is twice the distance between the lines. Okay, what this means is that this composition is two reflections across two parallel lines. Here's our two parallel lines. Okay, so I reflected the pre-image to the image, then I reflected this to the red triangle. And when you go from the blue to the red, what it actually is a translation across this vector here. And the measurement of this vector is the distance between the two parallel lines doubled. So you take this measurement and double it, and you'll get the measure of the vector. Okay, composition of two reflections across two intersecting lines is equivalent to rotation. Okay, what this means is the two lines intersect at this point, so there's your point of rotation. That this angle measure is doubled to get the angle measure of that rotation. Okay, so Sean reflects a design across line P. Here's your design. He reflects it across line P. Then he reflects the image across line Q. Here's line Q. So there's your final image. Okay? Describe a single transformation. You have two parallel lines. You reflected once, reflected a second. So the composition across two parallel lines is a translation. Okay, we want to know the distance of that vector. Okay, so the distance between the two parallel lines is 5 centimeters, and you double it. So it's 10 centimeters. Alright, any translation or rotation is equivalent to a composition of two reflections. I'm going to show you a video on this tomorrow that will help you, but I'm going to go ahead and try and explain it to you on this next one. But if you don't get it, I'll see you in class and help you with it tomorrow. Okay, so what this means is we have translation, pre to our image, and we need to produce the two lines of reflection. Alright, pick any two vertices. I'm going to use vertex Y and Y1. Okay, so I'm going to connect them. Alright, so first connect them after you pick any two. Alright, then what I'm going to do is I'm going to take the midpoint. I'm going to take the midpoint of that segment, Y1, okay? So that's what this point right here is M. Then I'm going to take the midpoint of segment YM. That's what this point right here is. Draw a line perpendicular to the first line, and there's your first parallel line. Okay? Then I got to take the midpoint of MY prime, and I get this point, and I draw my second parallel line. So this is kind of what we did opposite. You're giving the translation, and you've got to draw the two lines that are parallel. Okay, that's it, guys. Have a good one.